So what does the 95% and a 95% confidence interval represent? It represents the proportion of all samples that will result in intervals that include population proportion. Confidence intervals does not mean 95% probability. We'll get into that a little bit later as well. So here we're going to have a generic normal curve. Before we worked with a 95%, so now this will be for all. So 1 minus alpha times 100% of all sample proportions will result in confidence intervals that contain the population proportion. The sample proportions that are in the tails of the distribution outside the interval, so here's your interval that we're going to be finding. So anything in the tails will result in confidence intervals that contain the population proportion. So when alpha is 0.05, we're constructing a 95% confidence level. You can find that out by putting 0.05 in here, doing 1 minus 0.05 and timesing by 100% to get 95%. So what would your alpha be if we're constructing a 99% confidence interval? Your alpha would be 0.01. Okay, you can think of it 100% minus 99 is 1%, and then just convert that to decimal. Okay, and then if alpha is 0.003, we're constructing a, so put 0.003 in here, times by 100, we're constructing a 99.7% confidence interval. The value z sub alpha divided by 2 is called the critical value of the distribution. Right, this is going to be your standard deviations from the mean. So if you recall, we have the mean, and when you find the mean and add however many standard deviations times your sigma, and then subtract. So we've seen this before. Now we're going to call these critical values. Okay, because a critical value, it represents the number of standard deviations the sample statistic can be from the parameter and still result in an interval that includes the parameter. So it's pretty close to what we worked with. Now a critical value just takes it one step farther because it includes, it's an interval that includes the parameter. And this can be done on number 8 on your calculator sheet. So the table below shows some of the common critical values used in the construction of confidence intervals. Notice that higher levels of confidence corresponds to higher critical values. After all, if your level of confidence that the interval includes the unknown parameter increases, the width of your interval through the margin of error should increase. So this last table is basically saying as your critical value increases, so does your interval, right? Because the wider you get over here, or the wider this number is, the farther out it goes on both sides. So let's use number 8 on our calculator sheet to verify. I'd first like you to figure out what the alphas are in each of these. Kind of like we did up above. So this is 10%, convert it to 0.10. What remains from 100% is 5%, convert that again to a decimal, and then 1% and convert that to a decimal. So we're going to use number 8 on our calculator sheet. So let's find 90% confidence interval to get the critical value of second bars, inverse normal. So the value of the area to the left. Okay, so we have area in each tail. So for this one, we have 0.05 over here, 0.05 over here, and then 90% in here, or 0.9. So what's all the way to the left? To the left would be 0.95. And then the value mu equaling 0 and 1. And here you can see we get 1.645, which is right here. All right, so let's create one on our own. If you recall, we have the empirical formula. Within one standard deviation, it should be 68%. Within 2 standard deviations, approximately 2, you should have 95%. And within 3 standard deviations, what should it be? 99.7%. Excuse me, sorry. So our number, the critical value we are going to find, should be somewhere close to 3 because we're going 3 standard deviations from the mean on both sides. So this critical value should be pretty close to 3. Let's figure out alpha and figure out the area in each tail. So the area in each tail is going to be 0.003 because 0.3 remains from the percent, and then convert that to a decimal. And then divide by 2 to get the area in the tail. And then let's find it on our calculator. So we can do 1 minus the 0.0015 and then 0.1. So 2.97, very close to the 3 that we know from the empirical rule. Let's state the interpretation of a confidence level. A 1 minus alpha times 100% confidence interval indicates that 1 minus alpha times 100% of all simple random samples of size n from the population whose parameter is unknown will result in an interval that contains the parameter. So the Gallup organization conducted a poll in April 2017 in which a simple random sample of 1,019 Americans age 18 and older were asked, do you regard the income tax that you will have to pay this year as fair? We learned previously that the proportion of those surveyed who responded yes was 0.608. Gallup reported its survey methodology as follows. Results are based on telephone interviews with a random sample of 1,019 national adults aged 18 and older. For results based on the total sample of national adults, one can say with 95% confidence that the maximum margin of sampling error is 4 percentage points. Let's determine and interpret the confidence interval for the proportion of Americans aged 18 and older who believe the amount of federal income tax they pay is fair. So if you recall, we have 0.608. So if we want to create an interval, and we have the interval or margin of error is 4%, we can add 4% to get the high end and then subtract the 4% to get the low end. So 0.648, 0.568. So we determined them. Now let's interpret this confidence interval. We are 95% confident that the proportion of Americans aged 18 and older who believe that the income tax they pay this year is fair is between 0.568 and 0.648. You always want to use the lower number first and then the higher. So as you can see here, this is our estimation that we talked about at the very beginning of this lesson. We have our confidence level with our interval. This also needs to contain the population. And it needs to contain what they're asking. So that's up here. Okay, so you can see after you highlight it, there's not much left to be filled in. An extremely important point is that the level of confidence refers to the confidence in the method, not in the specific interval. A 90% confidence interval means that the method works. That is, the interval includes that unknown parameter that we're looking for 90% of all samples. We do not know whether the sample statistic we obtained is one of the 90% with an interval that includes a parameter or one of the 10% whose interval does not include the parameter. A 90% level of confidence does not tell us that there is a 90% probability that the parameter lies within the lower and upper bound.